All right, that's fantastic. Maybe we'll get started. So today what we're going to do is we will discuss a few things around DevOps. What is DevOps? What are the various tools that are used in DevOps? And then also look into how does a day in the life of a DevOps engineer look like? And then look at various career options for DevOps engineers. What are the entry-level jobs? How does the work look like? And also the salary for different roles within DevOps. And then some inputs around various books that you can read or certain good blogs, which will help you to improve your overall DevOps knowledge. And towards the end, it will be mainly around Q&A, where you can ask various questions through the chat. And then we'll have our panelist today, who's Sunil. Sunil is basically, he's worked in DevOps for a long time. And he's delivered projects across Australia, and he's been very critical to some of the projects. So Sunil will lead the session today, and starting with a bit of introduction, and he'll go through the slides. So this is a very interactive session, and Sunil is a practicing DevOps person, so he's got a lot of knowledge. So if you want to extract a lot of information, I would recommend you use the chat box to ask your questions, and he'll make sure that he'll answer your questions. So welcome everyone, and now I'll hand over it to Sunil. And Sunil, thanks a lot, and over to you.
Hey Raj, thanks for giving me the opportunity. Hey guys, I'm Sunil. I have around 14 plus years of experience in the IT industry, out of which I would say around 8 or 9 years in the DevOps stream or in the DevOps space. I'm currently working as a senior DevOps engineer, working on multiple projects at once, delivering both value to the company as well as infrastructure and other application deployment, or I would say guidelines and principles to an organization. Right now, as an introduction, I just wanted to understand: have you guys heard of the term DevOps, or according to you, what is DevOps? Right? If you could put those question answer this question in the chat window. I try to answer this and try to keep this session as interactive as possible. So yeah, go ahead and start putting in your responses to the question, what is DevOps? And according to you, what is DevOps, and what is the role of a DevOps engineer maybe? And then yeah, we'll see what we can discuss based on that. Right. Excellent. So I've got one response already. It says development and operations team integrated. I've also got another response that says DevOps is the integration between developers and operations team. So yes, you guys are right. So what DevOps team or what DevOps does is it acts as a bridge between the operations team and the development team. Usually, I wouldn't say all the time, but most of the time, these two teams tend to work in a very, very isolated or a sandbox kind of a way in an organization where developers just keep on punching out code, and on the other side, operations try to consume the code. The reason I say try is there is not that clean or a very valid way of handing over these packages of code to the operations team, and then the operation team work in their own silo. So for example, if something breaks in production, they try to fix it, and then they try to go about trying to figure out what happened, and that feedback never comes back to the dev. So it finally ends up as a mess. So a DevOps engineer is basically like a bridge between these two teams. Having said that, I'll just start the presentation. Probably this will answer most of your questions. What is DevOps, right? So DevOps is nothing but a combination of cultural philosophies practices and tools to increase an organization's ability to deliver applications and services at high velocity. Now, what does that mean? So coming back to the previous example of what I mentioned, where imagine the typical developer sitting at his desk, developing code, and yes, he does write excellent code, but then there is no way to hand this over onto the operations team or run this code in production, right? And the role of a DevOps engineer is to bridge that gap between the operations team and the infrastructure or the development team. Sorry, his role is to bridge the gap between the development team and the operations team to deploy this package or the application that he's developed seamlessly into production. And if there are any issues, feed it back to the developer so that that gets fixed very easily. Now, doing this is very easy, but doing this at scale, when I say scale, at large volumes, multiple times during the day. For example, if you take the example of Netflix, which I'm sure you guys have all heard of, Netflix does their deployment several times during the day. And we as end users, we don't even notice that a new release of there's something changed at the Netflix end. We just continue to watch our video streams, right? So this practice of delivering high velocity, high impact applications into an organization and helping the organization in its traditional software development practices, or even the infrastructure management practices, and being this bridge between these two is the role of a DevOps engineer. Now let's move on to the next slide. Now here you have a slide which probably explains a bit more of what I spoke to you before. Now, assuming this is the on the left-hand side of your screen where it says dev is the developer or the development portion of the organization. And on the right-hand side in this bottom box here, you could see the ops, which is basically your operations team or the team that runs the package, right? Now, how does sorry, let me quickly go back. I think I skipped a slide now. All right, so how does a typical software delivery process work, right? So the developers will first create a plan of what they need to deliver in terms of what they basically gather requirements from the business team. Now, assuming they're developing a website, it will probably be how many pages are there, what is the content of the web page, if there are any, I would say, images or videos or whatever on the web page. And then once the planning phase is done, the the development team then starts developing or creating the application. Now that will take some amount of time. And when that's happening, the developers then start coding their apps. Now that could be any languages that they use, and it could be in Node.js or Python or Java or any of these programming languages. And then they use tools to track the changes they make. We'll get into those tools, but I'm just trying to guide you through the process, right? Now, once they create those packages, they would then test it locally on their local machine, which is the verify step, which is the step at the bottom of the screen here. During the verification step, they wouldn't integrate it with the entire system. They would just run their tests locally to see if it works. Like if assuming the example again of a web page, they'll probably launch the website and see if the website works or all the images displaying and things like that. And once they feel everything works, they would then package it and then release it to the operation guides, right? Now, when I say package the application, it's more of creating a deployable version of the artifact or of the software that they created. Now, this could be a zip file, this could be a tarball, this could be just plain vanilla files, or whatever they wanted, right? So it's up to the dev to decide what it is. And once he's ready to release, he will then tell the operations team saying, hey guys, in operations, a new version of the website is now ready for you. Here you go, this is your package, and he just releases it. But the operation team have no idea that there was this release cycle that was planned, or there was a release package that was created. And this is where DevOps steps in, right? So this is where the DevOps engineer would be a bridge between these two and say, he would explain to the operations team what these new changes are, why it is required, what are the advantages of it, and he would then assist the operations team in releasing this software or the package into production. Right now, once you release it, that's not enough, because the developer might have added new functions or features that might need additional tweaking, or I would say changes or parameters to be set in production. So you then go ahead and configure your application. Now, once the application is configured and released, assuming everything works, it's live in production, everybody's happy, nothing's gone down, but then you need a way to continuously monitor your application. Right now, monitoring the application would be in terms of logging, assuming it's a website. Again, the example of Netflix, number of connections, number of active users, how many users are getting a good response, how many users are getting a bad response, what do you classify as a bad response, how many of you are getting invalid or a 500 page or whatever, right? So all these are in your monitoring statistics. Now, once you collect all these data, which is your logging data, you then feed it back into the development team saying, hey guys, when X number of users try to access this application, it fails. And then the development team would then go back and try to fix that again in the create step here. So this continuous feedback, or this continuous loop that goes on, is basically what DevOps is. And this is what a DevOps is supposed to do. He's the bridge between the development team and the operations team. And then he would constantly get the feedback from the operations team, feed it into the development team, and then the feedback from the development team is again passed on to the operations team. So this bridge, to fill in this gap, which is a very, very specific requirement in an organization, is basically a role of DevOps. Right now, continuing, again, based on the last slide, sorry. Most DevOps practices in an organization embrace agile technologies for managing work. Again, agile, there are basically a couple of ways of how you manage your work. So the terms are agile, scrum, and waterfall. These are the main three software development methodologies that are followed. Usually in an organization, especially in the last couple of years, everybody's on the agile bandwagon, where every organization is trying to follow the agile way of working. Now, again, agile itself is a huge concept, and it needs a lot of sessions to cover. But what agile is, it's basically, it enables features and tools to be iterated over many releases. So basically, splitting your work into smaller chunks of work, and trying to release smaller features into production faster, right? So that's what agile is. Now, when I say trying to release these smaller pieces of work, it just cannot be a single line code change or whatever, but it needs to be high quality, or a quality of that feature or the release that is made needs to be of exceptionally high quality. It needs to be, it needs to fix something, and then it needs to be done at regular intervals. What this interval is up to the team to decide, but it needs to be done at regular intervals. Now, again, agile is not suitable for all organizations. Some of them usually work with a combination of waterfall and agile. Like one of the last projects that I worked in had a combination of this model, where one team worked in the waterfall model and the other team worked in the agile model. And finally, when we released a package, we tried to follow the agile principles. Now, before I continue, probably stop here and then check with you guys if you have any questions. You can use the chat window to ask questions. There is a Q&A box if you want to ask questions, and then yeah, we'll go from there. Just a quick 30-second stop or a pause here to see if I get some questions from you guys. And if I do, I'd be more than happy to answer. Excellent. I can see people are responding, so which is good. Hopefully, I've made the concepts clear so far. If something is not understood or if you need an explanation, please let me know on something that you have heard so far. Cool. I would assume, yeah, there are no further questions. Now let's continue on this topic of DevOps. Now, so what DevOps involves is, like I said, trying to get a software delivery process in place in an organization where frequent, more reliable, high quality changes could be made. Right now, as part of this process, the organization then starts to implement a pipeline. I'll come to what is a pipeline probably in sometime sometime later in this session, or probably in the next session as well. But a pipeline is nothing but a consistent step in which a workflow is done. Right now, this pipeline enables automation of changes and modifications to the system through controlled inputs. So basically, it's now the system which is, or the automation or the machine which is doing the changes to the system instead of human input. And these inputs are now controlled by the machine. So we then have a consistent way of doing changes. Now, again, there is a clause in here, whether if it's completely automated or if it's partially automated, it's again up to the team to decide. Again, when I say team, it's mostly agile concepts here. The team can decide what they want to do and what they don't want to do. And once this is finalized, we then have a way to follow this release pattern here and then deploy it into the operations team, or the operations in production, basically. Again, what is a high velocity, and what do you mean by rapid changes across an organization? It's being able to integrate business processes more tightly with existing or new technologies, and that can lead to improved outcomes. So what does that involve? It's the time to market, lead time, mean time to resolution, and all these other metrics that you get from your IT or the operations team. Now, again, let's take the example of Netflix or Uber Eats or any of those companies. They do a lot of changes in production every hour, probably every half an hour as well, right? But again, for us, from an end user's perspective, we don't see any of these changes happening. Everything just works, and for us, it is basically seamless. Now, however, on the other side of that fence, we need to understand that they have gone through a lot of planning. They've gone through an activity of collecting a lot of metrics, and then deciding as a team, saying what works out the best for them and what gives greater collaboration between these two teams, so that finally there is a business benefit, and finally I would say profits that the business can get, right? From a DevOps perspective, all these changes that happen either in the development side or in the operation side, they need to be measurable. When I say measure, you need to be able to consistently see good quality of code being delivered. Again, there are tools that will let you do this, but then you need to be able to measure, for example, if there's a code change, number of lines of code changed, how many lines are removed, how many lines of code are added, is it a good quality code, or like static code analysis. And then once it's packaged and ready, time for packaging, how much time does it take to build that package, how much time does it take to create a release package. All these are measurable metrics that are available to the DevOps engineer. Like for example, for me, like in the last project that I worked on, we had a build pipeline, and the pipeline would take, I would say, 13 minutes to complete a build. And that's all the way from a developer checking in his code to a release package being available. And then these were broken down into steps. And then I, as a DevOps engineer, had to investigate what or where are these 13 minutes being used? What can we do to make this faster? Again, it's this high velocity, rapid change that the organization needs. The organization was okay with spending 13 minutes on the build pipeline, but as a DevOps engineer, I wanted to optimize it and maybe make it to 8 minutes or maybe 5 minutes, right? So this constant feedback loop that needs to be established is the role of a DevOps engineer, where you debug the system, you try to analyze what's wrong, you try to feed it back to the developers and say, hey guys, can you make this change so that the build happens faster, and then go through that iterative process over and over again, right? Again, doing all of this, what does it get? It gets us business outcomes. The business outcome is nothing but the profit, or I would say the number of customers that the business is able to retain as part of this change. Every organization works on this principle where they need customers to function, and as long as the customers are happy, the business is happy as well. So this is what a DevOps engineer's role is, finally, to make sure the business is happy and is able to deliver the results it needs. Okay, so before we proceed here, again, probably I'll wait for a couple of minutes again. If you have any questions, please let me know. If you think I've skipped over something, or if you need clarification on something, we can discuss. And if not, I'll continue again. Okay, so there's an excellent question here. It says, what's the difference between a tool and a process? Now, tool is I would say tool is something that would assist a DevOps engineer in performing his task. Well, not only a DevOps engineer, any I would say a technician or an engineer in a team to perform his tasks. If you see the picture up here, there's a tool called Git. Now, Git is nothing but a source code repository. It maintains and manages your code. So now that's a tool, right? Now there's a difference between a tool and a process. Process is basically a business or a team deciding how these changes are to be done, right? So there are multiple examples of a process, for example, a change management process or a release management process. So these are steps that are designed by the business or by the organization before any changes can be done in the operations side of things. So these are things that need to be done. Now, there's another excellent question here. Does the DevOps is only suitable for bigger companies who has frequent deploys? I would probably not say no. Again, you need to think of DevOps as a different idea, right? So it's an ideology between an organization. You can deploy it, or you can work on this on your day-to-day life, right? Doing continuous iterative changes to achieve high quality of work. To shorten that first slide that I had, it basically summarizes this. So doing rapid changes and breaking down the amount of work that you have into small iterative changes is what DevOps is. You could do this on your day-to-day life as well. It doesn't need to be only for companies who are huge. It could be done for a small company as well. Assuming you have your own business and say you sell, I would say, probably a burger, right? So right from the time you start cooking a burger and then you start delivering it to your customer, what processes or what tools can you employ to make this whole delivery process easier is nothing but having that DevOps mentality, right? Can you say preheat your bun and keep it ready so that when an order comes in, you could just put the patty on top and then start delivering it? Or can you make sure your And once you do this, this is where the continuous feedback comes in, right? You then go and ask the customer if this particular way of preparing things is good. If he says no, you then go back to your chef and then say, hey, this is not good. What else can you do to improve this, right? So this particular feedback loop is what DevOps is. I'd probably go to the next question. Is DevOps same as the old webmaster who's maintaining websites 20 years ago, or is it a fancy name of an IT admin or an engineer, right? I would say it's not a fancy name of an IT admin or an engineer, and definitely not the old webmaster. I gave you an example of a website because that's easily comprehensible by most of us when we say website, what it is. But again, it's a software development principle, right? And it can be applied to anything that happens in an organization, and it can be to any software. Now, a typical IT engineer could be in the operations team. He would be maintaining his servers, maintaining his, I would say, tools or whatever for quite a while. However, he is not contributing to an organization's growth. He's not doing this as a constant feedback to the development team so that he could improve the way in which the software is created, right? This loop that you see up here, where you constantly plan, build, test, release, operate, deploy, monitor, and then again start planning based on that outcome. That's the role of a DevOps engineer. Your typical IT admins don't tend to do this. However, there is a shift in the in this space where there is a very there's a very overlapping or a gray area there. But a typical DevOps engineer is, yes, he needs to understand what your IT systems are. For example, in the operation space, what servers you have, the hardware, the networking, and all that stuff. So yes, he needs to be technical, but also on the other side, he needs to be working, or he needs to be able to convey that message to the development team as well. Another question here. So we can break the chain to development and testing continuous rather than do the deploy every time. Let me read that question again. Sorry, 1 minute. Okay, so the question here is, so we can break the chain to development and testing continuous rather than to deployment every time. I guess what you're asking is, can this chain of continuous deployment and continuous releases be broken? Yes, look, you can definitely break this chain or break this constant feedback loop, but then you wouldn't be able to follow the DevOps principle or the DevOps ideology, where you have the whole ideology depends on you being able to deliver consistent, reliable, unbreakable or non-breaking changes into the system, and or introducing this into the system and ensuring the system always works. So finally, at the end of the day, you need to make sure the business is not impacted by any changes that happen in the system. The business should continue to work as it is while they start getting, I would say, profits in terms of business, but at the same time, ensuring the systems are also able to handle it. I hope that sort of answers that question. Okay, so there is another question here. Probably the question is, DevOps comes in picture only when we use agile methodology and not waterfall model. Well, not true, right? So waterfall and agile models are two different ways of doing software development. Okay, a brief explanation of what agile is and waterfall is probably will help. Let me start with waterfall model. Waterfall model is nothing but assuming there are 6 steps to develop a software. The development process follows a serial way of doing things, right? So only after step 1 is done, step 2 will be done, then step 3, then step 4, and then step 5, and so on. Again, this is not breaking your work into smaller chunks. So for example, a typical waterfall model is, let's say you have a new database to deploy, and you then go and talk to your IT team and say, hey guys, we need a new server to deploy the database on. You wait till this IT server team creates a new server for you. You then wait, go to your operations team, you then tell them, hey guys, a new server has been created. Can you install the database on this? And only after they do the database installation, you then go back to your development team and you tell them, hey guys, a new database is created. Please go ahead and deploy your changes or whatever, right? So as you can see, this is a series of steps that happen in a serial fashion, which is one after another. Now, what Agile says is you break down these steps into smaller steps, right? So you break down, for example, step one, or even step one, you combine step one and step two, and you break it down so that there is no wait happening there, so that it's seamless. So for example, while the IT team is provisioning the server, your operations team is already preparing the steps to deploy the database, or probably they would merge that task and tell the IT team itself to deploy the database. So as you can see, now we have shrunk the number of steps that are there, and the outcome is faster, right? So again, probably not the right example for this scenario, but I hope you get the idea. So DevOps is used in both models. So DevOps can be used where DevOps, even in the waterfall model, can try to bridge the gap between multiple teams and try to get things going faster. But the moment you start going faster, you then start following the agile methodology and not waterfall. So there is a huge gap. Hope that answers the question. Cool. Now, continuing on the slide, what DevOps isn't. DevOps is not something that you can buy. DevOps is definitely not a tool. It's an ideology. DevOps is not using the cloud. So for example, if somebody comes and tells you, hey, we are using AWS or Azure or anything of that sort, they're not doing DevOps. DevOps is not ping pong tables and beers. So it's not basically, what that means is the to and fro action that happens between, I'd say, the development team and operations team. DevOps is not agile. So if you use agile technology, that's not saying you're using DevOps. DevOps is not Kanban. DevOps is not one team. It's not one person. And yeah, open source is not always free, right? So that's what DevOps isn't. Now here, you can see on the screen, there are a couple of excellent books that I have referenced for you guys to read and understand what DevOps is. These are excellent questions that, these are excellent books that help you understand what DevOps is and what DevOps achieves, right? I've given the ISBN numbers on here. ISBN is nothing but the International Standard Book number. So using these ISBN numbers, you can search for these books on the internet. There are, again, 2 slides of these books. If you need these books or if you need these details, I'll send this to you separately, or I'll put them in the chat so that you could have a reference of this. So I'll just quickly glance over. Now, coming to DevOps tools, what DevOps tools are used in what phases of the cycle here. So let's start with the code phase. So as a developer, developer might use Confluence or Jira. Jira is nothing but a bug tracking tool. Confluence is nothing but a document management system. Git is your source control repository. So these are tools that a developer uses while he codes. And as part of your build system, you use either SBT or Maven or Ant or any of those tools to build your packages or whatever he has written in code. And to test his or her packages, you use Selenium or JUnit or I would say other tools here. So sorry, I got distracted here because I got a question on screen. There's a question saying, what is Git? Right. Okay, a quick introduction to Git. Git is a version control or a source control system where a developer can track changes to his or her source code and accept those changes if and when required. So there are multiple, I would say, source control or version control systems you might have heard of. One is GitHub, the other one is Bitbucket. You have lots more in GitLab, so you have lots more in the market, right? So these are all version control systems. They help you easily track and make changes to your source code, and then all these other systems assist you to take that source code and then either build them, deploy them, or run them on the system, right? Once your testing is done, which is again on a local developer machine, he then plans to release it using the release tools such as Jenkins, CodeShip. You might have heard of Spinnaker, which is used by Netflix. You have BuildKite, you have GoCD. There are multiple tools that do the release. And now you're into the operations phase where you then deploy it into production, right? So deployment can happen either on the cloud, which is AWS, or you could use Docker containers, ECS, and things like that, or even virtual machines, right? You could have them on-prem where it runs on hard virtualized machines, or even bare metal OSs. Once this is deployed in production, you then go on to the operate phase or the configure phase, where you use the configuration management tools to basically run or configure those machines, or sorry, the packages that you have deployed. The monitoring phase uses tools like Nagios, Splunk, Datadog. There are many tools that do all of these. I've just noted down some of them based on terms that you usually hear in an organization. And once this is done, you then, I think I press something. You then have the feedback phase where you plan again based on the changes that happen. So again, this is a continuous feedback loop. It just goes on this way, and the business is benefited from this. Right now, moving on. So yeah, there's a bit more explanation here of what DevOps tools are. They're nothing but technical or programming or coding inclusions that intend to nurture the software services, giving rise to quality output and improvement to the organization process and services. I guess we have talked on that probably, so I'll skip the slide. Right, so coming to explanation of some of the tools that we've used, or basically what we have listed here on the screen. Git, again, is an open source tool that enables faster release of development cycle. It provides excellent collaboration and enables easy and quick tracking of necessary changes in the system. When I say necessary changes, again, these are code changes, software changes, not system changes itself. Yeah, it's easy to maintain and manage multiple teams working on a single code base. Right? Another tool that I want to talk about is Jenkins. It's an open source DevOps tool that is used in continuous integration and continuous delivery. It uses a build system or a deploy system to deploy or build packages based on what you ask it to do. It's basically you telling the machine to do things, and Jenkins will just assist you in getting things done. Sorry. Next is Selenium. Selenium is, again, one of those tools that are heavily used in an organization. It's a software testing tool. It's mainly used for browser-based applications where Selenium would launch a browser in the system itself. Again, we can't connect to it as an end user, but it will launch the browser. It will open up your website, test the website, and then close the browser. So this can be repeated many number of times based on the application, and Selenium definitely helps you there. Docker, again, you guys might have heard of this a lot. Docker is one of the most popular platform to manage containers of an application. It assists in building, shipping, and running distributed applications as containers. Again, the advantage of Dockers are many. I'd probably have a separate session on Docker itself to get you guys up to speed and say what are the advantages of Docker. But again, Docker can be used to run any application anywhere, either on the cloud or on premises. Puppet is another system that we want to use. Chef and Puppet here is mostly similar. I wouldn't say similar, it is mostly similar or similar to what they do. It again helps you in configuration management, right? So assuming you have an application that needs some sort of configuration, let's say you need a username for a database to be configured in an application, or an environment variable to be configured. Puppet can do this for you in an automated way, so that every time you do this deploy here, this step, Puppet can come in and configure it automatically, and that way Puppet is really, really good. Now, before I move on, just a question for you guys. Have you heard of these tools, or am I going too fast? Have you used these tools before? Please respond in the chat window or the question and answer window so that I could probably answer them before I proceed. Excellent. I've got a response saying had a brief idea about these tools, which is good. That's really good. I've got another response that says I've used Git before, which is again really, really good that you guys are at least aware of these tools and know of what these are. I've also got a response that says I've worked with Selenium and AWS and Dockers and things like that. Excellent. So probably you know what the advantages of using these tools are. I've got another response here that says I've not used these tools, but I have an idea, right? Which is good. At least you're exploring what the current enterprise is using. And what are the current tool sets that are available in an enterprise for a DevOps engineer to excel in his day-to-day activities, right? I've got a response here which I'll take into consideration. There's a response that says I'm interested in learning more about Docker. Yeah, definitely on one of the things in my to-do list. I'd probably have a session on Docker specifically, and probably walk you through some of the things that we can do in Docker and how it can assist in software development and even software deployment, right? Excellent. I've got another thing here that says I'm aware of these tools but not have used them. Cool. Excellent. I'll just move on probably a bit more faster now. So another tool that's been recently in use in an enterprise is HashiCorp Vault. Vault is nothing but a tool for securing and accessing your secrets. Right now, every organization has secrets. When I say secrets here, it's not business secrets. It's passwords and API keys and SSH keys and things like that. Now, Vault is a tool that will help you tightly control access into these secrets, and it'll also provide a way of auditing who's accessed what. Now, one more excellent tool here is Packer. I'm not sure if you guys have used or heard of Packer before. Packer is an excellent tool that I use every day mostly to create golden images for my machines. Whether I use Docker or AWS or Azure or Google Cloud, I use Packer to create base machine images from OS ISOs and pre-configure these machine images so that when they are spun up, it has everything ready for and available for the team to use. So that way, Packer is excellent. Probably we can do a session completely on Packer. Vagrant is another excellent tool which goes hand in hand with Packer. Using Vagrant is a tool for building and maintaining and managing virtual machine environments in a single workflow. It focuses on automation. So what it does is, or what I use Vagrant for is, I create machine images in Packer. I then run those machine images in Vagrant just to make sure it all works, and then I deploy it into production. Now these go as a pipeline, and all of this happens automatically. But yeah, it's an easy way to configure, reproduce, and have portable work environments in Vagrant. Again, one of the leading DevOps tools that is there is Terraform. Terraform is used to mainly to configure infrastructure on the cloud or on-prem. It does an excellent way of maintaining and managing infrastructure, and is one of the top tools or top, I would say, skills that a DevOps engineer needs to have. There's a question here, or basically a pun. Is Packer the same as the person who owns the Crown Casino? Well, unfortunately not. Packer is an excellent tool. I'm not sure about the guy who owns the casino. But yeah, have a look at Packer. I'm sure you would be surprised at what it can do for you. Continuing on, you have Ansible. Ansible is again a configuration management tool. It's very, very easy to do this, or basically write code in Ansible and have it configure your system, your application, or even your entire software development processes, right? And it works on ID impotency, which basically means if you run the same task over and over again, if there are no changes will be made, right? It'll just skip over these tasks. So that way, Ansible is excellent, and Ansible can configure 90% of the stuff. I've got a question here. I'm waiting for the question to pop in. One quick question. Okay, I'll wait till when the question comes up, I'll probably come back to it. Again, ELK stack, which is nothing but Elasticsearch, Logstash, and Kibana. You might have, or you might hear these terms when you start exploring an organization where these tools are used to provide insightful data and logging capabilities in an organization. As a DevOps engineer, you'd probably work on these tools on a daily basis, trying to understand this particular monitoring section of the continuous feedback loop here, where you take inputs from these tools, you try to explore or query the data you have in terms of, again, the example of Netflix, number of users visiting a site, number of users who can actually log in, number of users who can't log in. So these are all the metrics that this particular stack can provide. Of course, it needs a lot of configuration, but once correctly configured, it can provide you insights into this, and that will definitely help you in your next planning phase. Splunk and Nagios is somewhat similar. I'll just skip over it for now. All right, I have a question. Does DevOps engineer has to be aware of each and every tool? I mean, does he has to be master of every tool? Okay, look, you don't have to be a master in every tool, but it's good that you know some of these tools, right? Now, assuming my example, I have years and years of experience working as a system admin and then as a DevOps engineer. But some of these tools, for example, Datadog, I've not used that system before, but you get an idea as soon as you see it, what it can do. And it is somewhat similar to what Splunk or even the ELK stack can do. And once you have an idea of what it can do, I'm sure you'll be able to explore the tool a bit more and try to get some things out of it. So you don't have to be a master of every tool. Again, you can't probably be a master of everything, because by the time you start mastering all of these tools would have then evolved onto something else, right? So for example, okay, another question here. As a starter, which would you recommend to start with? Probably going on based on these two questions. Look, every phase of this particular life cycle, if I could quickly go back to that screen here, every phase of this life cycle, there are some tools which is good to know about, or which is really good to have knowledge about. So for example, in the code phase, you definitely need to know Git, right? And Jira is nothing but a bug tracking tool, which is a web page based application, but you can have knowledge on these two tools. On the build phase, yeah, definitely Maven and things like that. If you're into testing, JUnit and yeah, Selenium probably. And yeah, if you want to focus on what you want to get out of being a DevOps engineer, right? So if as a developer, you probably want to start with Jira and Git, but if you're into operations and infrastructure or whatever, then you can start with Docker, AWS, Ansible, Kubernetes, and these tools. But you definitely need to, for example, know one of these release tools like BuildKite or GoCD or one of those tools, right? So you definitely need to know this. Again, you don't have to have in-depth knowledge of how it works because not everything is used everywhere, but just having an overall idea of what these tools do would be good. All right, so a couple of questions have popped in. Let me quickly read them. I guess, okay, there's a question here that says, as a starter, which would you recommend to start with? I guess I've answered that question. At least we have to be aware of how they can be used. Yes, probably that's a good idea to be aware of these tools and see where they fit in an organization's workflow, because most of the organizations, I would say 90% of the organizations use these tools, right? But if you want to be a DevOps engineer, then yeah, okay, probably not. Question, what exactly is Elasticsearch? A search tool where we input something and fetch the required output? No, Elasticsearch is, again, that's a huge topic to discuss, but as a synopsis, I would say you feed it some data, or for example, a log file. It will scrape through the log file and index key values in those log files. Or basically, if you have a single log file, it'll break it down into multiple indexes. And now it'll give you the ability to search on those log files. So for example, if you have a huge log file and it says, let's assume it has 10,000 lines, and right now you could feed Elasticsearch this log file. And once it's processed reading this log file, you can then now start querying it and say, give me lines of logs between start time A to start time B, and then it'll just give you those lines. That way, so you can narrow down your search. Again, it's an excellent tool that you can learn. It's really, really good. There are many requirements right now in the market where they need experts or people who know Elasticsearch in Australia, and that way it's really, really good. Right. I'll just quickly continue. Right. So coming to tasks of a DevOps engineer on a day-to-day basis, the first one that says infrastructure design, probably not for a DevOps engineer, but probably for a senior DevOps engineer. So for example, me, I do work on infrastructure design. I try to give or create environments that match the business requirement. So probably designing the infrastructure is more for a senior DevOps engineer. Designing a setup for new users for better interface that's automated and intuitive. Maintenance activities on a server. Monitoring, visualization, again, development technologies, load balancing, optimization of applications. You can read most of this on the screen, right? So CI/CD and things like that. Again, the DevOps engineer tells the team or assists the team in keeping all the code changes into a single system. In this case, or in the screen here on the top, which is Git. Monitoring the feedback that the operation team are getting in terms of a new release of a product or whatever. Sorry. Scaling systems, for example, networking appliances, load balancers, applications, and things like that, right? So you get to play with a lot of hardware and software kind of side of things. So in the operations side, you definitely work on IT and infrastructure and things like that. On the dev side, you definitely work on code maintenance and management and reporting and metrics and things like that. So yeah. Now coming to the expected salary in Australia for a DevOps engineer. Again, this is from our website, PayScale, not my own research, just to give you an idea of what you could expect. If you choose for a career in DevOps, you could probably start with the minimum salary that's there on the screen, but you can see how varied or vast the bracket is, right? So you do have a lot of people hiring for a DevOps engineer right now. And yeah, there is a lot of variation in this based on your skill sets, what you know. And especially in the previous slide, as we discussed, if you have an idea of these tools, yeah, you'd definitely be on the higher end of the scale. Cool. Any questions? Do you want me to pause or should I continue? Any questions? Cool. I would probably continue, assuming we are a little bit above time. Again, in probably an expansion onto what we discussed before. It's basically showing you how much you could expect if you decide as a career path, right? I've got a question here. It says, is DevOps engineer role offered to a fresher with no experience? Look, that's a tough one to answer. Now, when you say no experience, if you're right out of your university, if you have a little bit of experience using these tools, I'm sure you would get an opportunity as a junior DevOps engineer, and then you can slowly start picking up on your skills. Having said that, I'm not discouraging you from trying it. Please try for these, I would say, opportunities. But in the meantime, try to learn these tools and tool sets and see what they do as well and see where they can help you. Probably first start as an engineer as well, and then try to learn more about these tools. It'll help you, I would say, get knowledge or experience, and then you could slowly transition into a DevOps role that would make you enjoy both sides of the world, right? I'd probably proceed. Probably the last slide now, the last one slide. There is also another term that's highly used in the DevOps space, which is the DevSecOps or the SecDevOps. Most of them, or both of them, mean the same, but it's more focused on the sec word here, which is security, right? So usually in the typical software development process, you will or the security of that particular process always comes towards an end, mostly in an organization. But as a DevOps engineer or a DevSecOps engineer, your main role is to bring security to the forefront. So usually DevSecOps focuses on shifting security to the left, which is, when I say left, it's to the left of the software release cycle. This means rather than adopting an incident response system, which basically means responding to something that has already happened in a system, which is basically a software incident. For example, most of you have heard a couple of days ago, 9 News Network was hacked and things like that, right? So again, this is, I'm sure they would have an incident response system. They would have a process to manage that attack vector or whatever it is, but trying to start with security in mind. For example, principle of least privilege. So you just have the right amount of privilege for you, for the work that you need to do, is basically the principle of least privilege, right? So following these models to work is basically DevSecOps or SecDevOps. Again, using tools like Terraform, Puppet, or Ansible to create consistent environments or consistent application deployment patterns, and having these patterns constantly analyzed through some security scanning tools will allow you to achieve this as well. Again, monitoring aspect is somewhat very, very important, because only when you monitor these systems and tools, you would know if something's gone wrong. So continuously monitoring the production environment for any active security threats is something that needs to constantly happen, and that feedback loop starts all over again. So probably that's what it is. I've quickly run through a couple of slides at the end, but yeah, having said that, any questions? All right, a couple of them coming in. Which programming language would be mostly helpful, Python or JavaScript, to our DevOps engineer? Look, again, if you're trying to focus more on the infrastructure side of things as a DevOps engineer, so for example, me, I focus mostly on operations side of thing, and then I do go back in the feedback loop and go back to the development team and try to tell them or explain to them what the problem is. So I tend to focus more on Python, right? So Python, although is an excellent programming language for either applications, it's also an excellent programming language in the operation space or in the infrastructure space. So depends on what you want to focus on, but both of these are excellent tools that help you achieve the result you want. So it's up to you on where you want to focus. I've worked on at least one DevOps tool in each stages except that of configuration stage and monitoring stage. Can I still apply for DevOps role based on jobs? Yes, look, definitely. Look, like I said, you don't need to know all of these tools to start working as a DevOps engineer. For example, like I said, I do work on the monitoring stage or in the operation stuff. But again, the things that I do, for example, on Nagios or Splunk is very, very little. So I'm not an expert on these tools, but I know how to navigate through these tools. Now, if you starting, you might not know these tools, but as long as you have an idea of what these tools do or how to query these tools or how to get the expected results, you can definitely start working on them, right? So for example, if you're interested in learning, let's say Splunk, right? You can definitely run Splunk locally on your machine, explore it, see if it works. And if you're happy, yeah, that's some knowledge you have gained. And definitely that will help you when you apply for a job. There's another suggestion here. Can you please share this PowerPoint? Yeah, this will be shared by Raj later. So yeah, definitely you can talk to Raj on this. Cool. That probably comes to an end of the session. Raj, are you there?
Hi, Sunil. Thanks a lot for a very insightful session. I also learned quite a lot in this session. Thanks for that. Thanks for sharing all this information that you have gained over the years. And with regards to everyone on this call, I would like to know if you could share your experience in the chat, saying if you would like to rate it between 1 to 10, 10 being really good, and 1 being very bad. I hope it is not 1. So it'll be good if all of you kind of vote, please. And then we'll design some more sessions in the next presentation, and we'll give a lot of hands-on experience, and we'll do like a mini kind of project. So those things will be shared, and another webinar will be created. So you can get to use some of these tools as we learn a bit more about DevOps.
Cool. Thanks, Raj. Again, thanks, guys. Although we're not having this discussion on the call, I can see the chats coming in. Excellent feedback. Thanks for that, guys. Definitely look forward for the next session. We probably have a lot more things happening in terms of what we deploy and things like that. So me and Raj are trying to develop that next session shortly. And yeah, thanks for your time today.
Thanks, everyone. And we'll stay in touch over emails, and have a wonderful evening. Once again, thanks a lot for your time, Sunil, and looking forward to helping people learn more about DevOps.
Definitely. Thanks, guys. Have a good one.
Bye-bye.
Bye.